Hi, I'm Dave Robinson, and welcome to another screencast where I'll be using R to analyze data that I've never seen before. As usual, this data comes from the Tidy Tuesday project. It's a great project run by the R for Data Science online learning community that every week releases a new data set. So let's see what data set I have this week. Looks like it's global plastic waste. All right, so we're looking at plastic pollution. We might be making a map today. Let's see. They're an uncleaned. Oh, great. Janitor clean names. All right. Yeah, so we can practice a little bit of data cleaning. All right, let's see what kind of visual is. We have coast versus waste, mismanaged versus GDP, waste versus GDP. Let's take a look. I'll start with one of these data sets, see how we need to clean it. I usually do library tidyverse, and I set my ggplot2 theme. Plastic waste. Save the file. Fantastic. Right. All right. Looks like we're working by across countries. We have 3-letter country codes. We have over time. Oh, good chance we'll make an animated graph. We're gonna try the janitor package, as suggested in the README. I think it's clean names. To turn them turn them into snake case. It's pretty handy. So we see entity, code, year, mismanaged plastic waste in tons. All right. I wonder if I summarize all. If I say for all of these, what fraction are NA? Wow, almost, so strange. In this data, almost all the data here is NA in terms of mismanaged plastic waste. So if I did filter, it's the same amount across these two. So I filter, not is NA coastal population. Oh, I only have it for, let's find out how many years. I only had for 1 year. All right. So I'm actually going to remove year to remind myself and not tell myself, and I'll call it coast versus waste 2010. So that was a little bit of data cleaning I'm doing at the start. All right. So that's one bit of data we have just for this country. Now let's take a look at managed versus GDP. Same thing. I'm going to look for not is NA. Oh, I'm first going to clean names. And it's waste presumably. Oh, let's see. I can find out what the call names are with call names. Oh, wow. It's a whole very long name. I am going to do some renaming. I'm going to say mismanaged waste per I'm not going to say per person per kilograms per person per day. Also, per capita and per person is sort of redundant. I'm just going to say, let's see. And GDP per capita is this longer one. And I'm finally going to filter not is in a mismanaged waste. It does look like I'm missing some, and also only 186. Let's take a look. Count year. Yeah. So we have so this data, the data was like we said, intentionally unclean. So one thing we learned as we work with data is we're not going to do anything over time, at least with these two data sets. How about this one? All right. So one thing I noticed at this point is that all of them, what we really have here. We have the same process that needs to be run through each of these. Okay. If I said waste here, waste versus GDP, filter not is in a clean names. I really only have a handful of metrics. Oh, I already looked. Did I look at? No, I didn't look at this. Waste versus GDP. So this is waste versus GDP. This is mismanaged versus GDP. And what was this one? All right. Here's what I'm learning in this process. We actually only have a handful of metrics that we're pulling in here. Uh, and we don't really need, let me see. We have GDP, we have population. I'm going to do a little renaming. So I'm just considering doing like some joining. Okay, I think what I'm going to do is write a quick function called clean dataset, since we're applying this to all of them. And we're always going to, I actually think, rename entity to country and country code equals code. And we're going to filter for year equals 2010. That way we don't have to do these other filters. And let me quickly check something. Yep, all of them are 2010. So here we got clean data set. And at that point, what I can do is basically clean each of them and then join them. Yeah, I think that might actually be a bit of an easier approach. So I take, let's say, our first one, clean data set, inner join with clean data set of mismanaged versus GDP by country and country code. We probably could have just kept one of them. Country and country code. Can't join oh, oops. Anyone else catch that? And I can do another join with a cleaned version of the other data set. I like to avoid too much repetition. You don't have to get like, you don't have to do too much of this kind of renaming, but it's nice. I also notice we have total population gapminder in at least 2 data sets. I'm going to remove it from the first one. Oops, I need to put this up here. And we don't need year. All right. So now I actually have more information about, it looks like there's things I'm still missing from each of them. For example, here, filter year equals 2010. Was I missing Afghanistan? Yes, I was missing stats on Afghanistan in this one. All right. I run through this, and we actually notice there's there's actually quite a bit of missing data. Total population gapminder looks like it's in all 3 data sets. I just went ahead and removed it from another one as well. All right. All right, so what we have now is country stats. And I'm going to do a little bit of renaming to make these smaller. What we have is tons of mismanaged plastic waste. So we said, so I'll rename that as mismanaged waste. Coastal population is fine as a name. Total population, I'm going to grab just total population gapminder out. And then we have, let's see, per capita mismanaged capital waste per day. Oh, I see, a coastal population. Okay, so this is mismanaged plastic waste kilograms for the entire country. And then we also look at the fraction living on the coast. All right. So you might be able to say, is there more mismanagement for countries that have large coastal populations? Is there a reason for that? Does it get dumped in the adjacent ocean? I'm not sure. We'll take a look at that. Mismanaged per. So I'm going to call it mismanaged per capita. Then I'm going to say, we have GDP per capita. Wow, this is a whole long thing. I'm going to skip most of that. I'm missing something. Oops. Mismanaged. These two should go here. I'm going to delete these later. This later stuff. I was just... oh. If I need to rename, I don't need to do it. Okay, so I'm still missing a few. Oh, I meant to do a select rather than a rename. Because what I actually am doing here is going to say country code. I have it for 235 country. Oh, I'm going to... The ones where we don't have things like the mismanaged waste, we generally, it looks like we also don't have it in mismanaged per capita. It's not that useful to just have population GDP per capita. So I'm going to say not is in a mismanaged waste. So here's our relatively clean data. It looks like we don't always have GDP per capita. We could probably get it through the WDI package, which we've used in 2 recent screencasts. But for starters, I'm going to say plastic waste. Here's our cleaned data set. All right, so this was data cleaning. Notice what we did. We needed to combine 3 data sets that were mostly, that each had a couple of variables in them. They had long column names written in English, not the kind of variable names we want. And importantly, they had entirely missing data except for 2010. So we filtered down to that. So this is probably the similar kind of thing to what the people running R for data science, particularly Thomas Mock, would have done in advance. So, all right, 15 minutes in, we've done some data cleaning and we have our clean data. Let's take a look at it. Let's get a feel for our data by putting it in view. Okay, I am going to start by sorting by mismanaged per capita. So it looks like mismanaged, this is waste in kilograms per person per day. So in Sri Lanka, it's just Vanuatu. Here it's just there's a high level of waste relative to the number of people. So we can make a couple of make a graph for this, but actually, let me take a look at it one other way. Look at the biggest countries in the world and ask how do those countries what level of mismanagement is there. 3 biggest countries in the world by population are China, India, U.S. It looks like the U.S. has China has a far greater amount of mismanaged plastic waste. That's wow, that's remarkable. 10 times higher than India or the United States. Pakistan, Nigeria as well. So it's interesting because China is generally a richer country than India. Gapminder has China as an upper middle income, India as lower middle income. We see the GDP per capita is twice as high. And I would have expected mismanagement per capita to be correlated with country income. So let's take a look for a moment. And it looks like it might not be as simple as that. Let's take a look at a comparison of GDP per capita and mismanaged per capita on a scatter plot. When we do these, we almost thought we're basically always going to need certainly the x-axis to be a log scale. Taking a quick glance at that graph, we need the y-axis to be on a log scale as well. And we could have told that by seeing the fact that there's such a big difference between India and between China and the United States. So one thing we see is that very rich countries that's in this group generally have a relatively low rate of plastic waste mismanagement, and poor countries have a high rate, but it's not that tight a correlation. We can in fact see the highest level of mismanaged plastic waste happens in Roughly middle income countries. We saw this was about China's GDP at 10,000. So that's that's one interesting conclusion. Let's see. I'm gonna quickly clean this up a little by doing labels, comma format. I need library scales for this. I don't love the scientific notation here. Oh, it should actually be dollar format. GDP per capita. Y is mismanaged plastic waste per person per day. Yeah, so we see this kind of trend where the peak is up here. I'm gonna go ahead and add a size equals total population. So you can focus a bit on like India, China, United States we already saw. And India, that really is interesting, has this is what we call it has a very negative residual. It's very far below the trend. We see a general trend, but there's countries like India that are beating it. For countries that with India's level of income, you would expect it a lot more plastic waste than there is. We can take a look then at I might consider filtering out smaller countries. It'll make it easier for us to add some labels to this. We can say total population greater than 1 million. Yep, I think it's pretty good. Shape of the map looks a little like Italy, but I suspect that might be a coincidence. Geom text, AS label equals country. This is especially handy with check overlap equals true. This lets us add some points to the graph. Ooh, and makes me realize that I need the size to affect only the points, not the text. It's going to look a little weird otherwise. Here we are. So we actually can see each of the country names. One of the challenges here is that we probably want the biggest countries to pop up if there's can only be one country or the other. How do we manage that? We need them to pop up lowest on the graph so we can arrange in ascending order of total population. That puts them first on the graph and makes the later ones the overlaps. Is that right? Where's the United States? It doesn't quite look like it worked. Did I get the direction wrong? Yeah, I guess. Oh, of course. I meant greater population had to be at the top. All right. I was thinking. Here we go. Now we can see like India, Jamaica, unusually low plastic waste for their GDP per capita. Sri Lanka, high even for its level of income. And we see lots of countries like Siberia, Congo, Sierra Leone, Mozambique, very low income countries, still just don't have that much. They have plenty, but not as much as like some of these middle income countries. But yeah, mostly what I'd say is only rich countries have have plastic waste, what you could maybe say under control. At least this is the story that I probably would have looked at. All right. One thing that's interesting to me is it says they're already in good shape minus the column names. But does it look like they're in good shape? I really don't see any data over time. Surprising to me. I would have thought that would have been more clean, but that was just me taking a look at this data. Is there somewhere else we could have gotten it? No. Well, let's take a look. We go to war with the data we have, not the data we want. So here's one visualization, like I said, that we had in terms of plastic waste, and I just want to we wanted to take a quick look at that. I'm doing something else. Does it have some relationship to coastal population? So, and maybe coastal population is a fraction of the total population. So I would say percent population coastal. I'm mutating on a variable that is coastal population divided by total population. And now I'm going to visualize, I'm actually going to keep, most of this. I sort of just want to take a quick give a try at how can I how can I take a look at the connection between idea of connection that might exist between these. So I could put the y-axis on a log scale, and yes, I might. So one thing we're seeing from this that I think is pretty clear is what do all these have in common? I'm pretty sure these are all islands. And islands have both, of course, a large percent of the population living on the coast, and as well as it looks like a real problem with pollution. One thing we see here is somehow we have greater coastal population. More than 100% of the population lives on the coast. And I don't care how nice your coasts are, you probably don't have more than 100% of people living on them. Well, that means I think we might have picked a population from a different year at some point in this analysis. Let me take another look at the data set that was called coast versus waste. If I look just at this one, oh, that's right, they've been cleaned. If I actually just look for, is coastal population ever greater than total population Gapminder? Yes. So this is it. Yeah. So this I think is one of the reasons that we didn't. What is it says Gapminder is that they don't necessarily agree entirely. I'm going to go ahead then and we could try getting the population other ways. Maybe they'd agree a bit better. But I'm going to start by doing a p-min of 1 on this to ensure that it can't go over 100%. The other data isn't necessarily accurate, but it's something worth looking at. It's at least like somewhat meaningful. All right. Sri Lanka. Is Sri Lanka an island? Yes. Sri Lanka's an island. I'm pretty certain Guyana is. And I'm pretty certain all of these are. Yes. So what we're seeing here is so that's one of the first things we can learn is, and that might explain, interesting. This might help with our questions about why were there so many middle-income countries with the highest level of plastic waste. We might have wanted to add that to that visualization. So I'm going to say is add this, and we'll throw in one of is island, and we'll say, I don't know, like most of let's say if the coastal population is greater than some amount. If percentage population coastal is greater than, I mean, many countries are islands in some sense. North America is an island, but it is a continent. Indonesia is is a very large number of islands. So it's kind of hard to say for sure what is defined as, I'm not going to say is island. I'm going to say high coastal population, and I'm actually going to set it at 90%. Panama's not an island, Haiti is. I don't have a perfect link here, but what I'm going to say is, high coastal pop. I'm adding this to my original graph with GDP, and I'm going to throw in actually a subtitle before I forget to say, not a subtitle, I'm actually going to do a color equals greater than 90% coastal population. Does this say what definition of coastal population is? Veneer, it doesn't. By this definition, Trinidad and Tobago didn't make it. I'm going to try 80%. I want to see if I get... Yeah, it's not really lining up. This is very strange, because I really thought that most... Let me try without a log axis for a second. Am I missing something? I thought we saw that that a lot of them had really high, a lot of the high mismanaged plastic waste. Like, where are all these countries? Oh, I did a filter. Ah, there they are. I was like these two graphs didn't seem to be lining up. So I need to decide actually, should the y-axis go on a log scale? When I did the pattern got a little more linear. It's hard to say whether it's as meaningful. I'm going to do a log scale, partly because that was our first. We originally plotted. I don't want to manipulate the plot we make to try and like change the interpretation. But another is that yeah, it gets across like you focus less on the few extremes and more on the general trend, and you can see this makes it clear that really rich countries are the only ones that make below 0.01 kilograms per person per day. All right, so that's some things we learned about plastic waste, and the relation between these two. I'm still just looking. It's like, yeah, high coast populations. A lot of these are islands, but not 100% of them. Don't know how much I don't know how much it adds to the visualization, but we'll finish it up and we'll clean it up. All right. So one thing I'll do is greater than 80%, less than 80%. Color is coastal population. And I was at a title. I'm missing a comma somewhere in this line. So in this line, let me see. Oh, and then parenthesis. So I'll say how plastic waste mismanagement correlates with country income. Subtitle was based in our world in data 2010 numbers. All right, and what other things would I do? I would make this size continuous be labels, comma format, comma. Yeah, why not? I could probably skip it. I could skip the size thing entirely. I would say scale size continuous guide equals false, I think. And I can get rid of that. And I can also mention that in the base size represents total population. All right. With this, let's see. With this in mind, what I think I might do, I'm interested about this communication challenge. What can visualize? Oh, sorry. I'm reading this. Let me see. Well, I'm unlikely to submit to this. But I'm going to think what kind of visualizations I can make. I can certainly make a map. Let's make a map. It's always fun to make maps. And think for a moment what approach I'm going to take to join this data set. All right, so we've done choropleths before. What we do to get a choropleth is we do map data, countries, it's world, Tibble diff. Is it already a Tibble diff? Nope. So it's a good thing that I did this. Region will generally line up the country, but not entirely. There's a data set called ISO 3166. That connects the ISO names to the map names. All right, so what I can do is take my plastic waste data set and filter, let me see, nope, inner join with ISO 3166 by country matching to ISO name. Which didn't match. An anti-join is always a good idea. You know, instead of country, I'm going to do it based on the country code. Ooh, that's a lot of letters. And I'm going to say country code equals A3, which we saw was matched the other one. Oop, did it? Capital A. No, A3. Oh. I seem to be missing, a C here. There it is. All right, and good. This gets almost all of them. All right, so we're going to stick to this one. All right, and we have joined with, yeah. Now that we've done that join, we can inner join to map data world by map name equals region. It's not map name. I wonder what I'm missing here. Oh, I still have an anti-join. Anyone else catch that? Make it 2 inner joins in a world. Yeah, in a row. So it took me a little remembering exactly how to line this up, but now I've used country code. Notice that like whenever you work with a data set with countries, they might have some subtleties for how the country names work or how whatever works. But yeah, and then we're gonna have to match it to one on like this choropleth data. This has longitudes and latitudes, which is great for making a visualization. What I'm gonna say is AES. My bad. Long matches up to X, lat matches up to Y, group equals group, and fill equals, actually going to skip, I won't do the fill yet. I'll do a geom polygon to show the trick that I'm approaching. So this is how we should set up our visualization, our graphs in the first place. One thing this makes me realize is we need to right join with the map of the world. There's some countries we seem not to have data on. And once we've done, and yeah, we're definitely gonna have to take a closer look at some of those. But now we can throw in a fill equals and whatever our metric is. So we want to start maybe with mismanaged per capita, our most interesting one. We're missing China, so something's up because there should, there definitely is China in the data. CHN. Is that not matching up here? It matches up twice. That's discouraging. Oh, no, it's not. There are two. Oh, yes, I completely forgot. All right. Map name, yeah, these take a funny shape. All right, so one of the challenges of this data, oh yeah, I'd completely forgotten this. The challenge of this data is that it actually gives a regular expression, not a string. So if I want it to line up, I don't remember the officially suggested approach for it, but what I use for this is fuzzy join. Fuzzy join is one of my R packages, and it can join based on a regular expression. So I can say, let me see. I can say this is our plastic data, and now I'll take. I'm gonna say map data. Triple diff. Don't forget that. Right regex. Sure. Well, the regex is the map name. So the reason I flipped this is I need the regular expression to go second. And here, map name is a regular expression. So so I can do a right, is it a right reg, oops, nope, it's a regex right join. So here we do a regex right join, plastic, and flip the direction of these two. Hopefully this puts back China. Yeah, there we go. All right, so that's an approach. I did a right join here, but I need to switch it to a left join to ensure we have everywhere in the world. Now we have some gray we still have some gray missing countries. That's certainly Antarctica. I actually sometimes like to, after I do a join, say filter region is not equal to Antarctica. It just clutters up your graph. I can also add a coord map. They'll fix the dimensions on this a little bit. Just grab some water. I'm going to skip coord map because somehow I accidentally, oops, that didn't work nearly as well as I hoped it would. I think that has something to do with if you cross over the, I think it's from a country that crosses over the international date line. Which would be about here at 108. No, it should be out here at 100. Yeah, at 180 degrees. It would be out here at 180 degrees, and apparently this doesn't handle that well. The coord map doesn't handle that well. I am going to. It's not quite as good, but I'm going to say coord fixed. We should just filter out that country. It's so confusing. But I'm going to say coord fixed. On a ratio, does this 2? Does this mean wider than it is tall? This looks fine as a graph, better than some other things might. I'm going to try adding a GG themes as a coord map. Oh, I'm sorry, a theme map. All right, and we've created a choropleth. Yeah, I'm looking around here. One thing we realized is we want to go back to a log scale. Otherwise, we just are really highlighting a handful of countries with a really high rate. I think this is Sri Lanka. So what I'm going to do is add scale. What I'm going to do is scale fill continuous and add trans equals log 10. Here we go. And this would suggest, and then throw in some labels. So we see some real geographic trends here, which are even stronger than the GDP trends. So we're going to take a look at this for a moment. We'll try theme, not a theme, labs, fill equals mismanaged plastic waste per cap, long otherwise, where the world is waste mismanaged. We already saw that India was an outlier relative to most countries with similar GDP per capita. Here we see it's also an outlier for its region. There's kind of a stretch of a lot of countries that have high rates of plastic waste across a lot of Africa and through Middle East, Asia. Well, China we already saw has a really high rate. Excuse me, as well as like Southeast Asia, like Indonesia. We can pick out that high income, what we saw earlier, which is high income countries, Western Europe, US, Canada, Australia do have very low rates of and Japan. So we do see income playing a role, but we also notice that it's also fairly low. Rates of waste mismanagement is fairly low in South America as well. Despite that having not too different an income distribution as say Asia. So this is some things we're learning about the geographic trends we might be able to pick out from a choropleth like this. If we had data over time, I'd look at it as an animated choropleth. Looks like we haven't gotten that yet. I'm going to ask a question about this, which is, what other data can we bring in that might be interesting? Whenever I look at, we build our map, now we say comparing to other country stats. One thing I'm interested then in is what other environment variables can we get from WDI? Let me see. Wow, lots of things. Greenhouse gas emissions. That's certainly like a generally relevant and important one. I wonder, yeah, I wonder if I did WDI search. I don't have anything on plastic, but let's see pollution. Lots of water pollution by industry. It's going to be missing on almost everything, I guarantee you. CO2 emissions, KT. All right. I want to grab that one out. So what I'm going to do is do WDI, what's it called? WDI of this. Oh, I'm sorry. I need to say WDI indicator. This, and let's do start equals 2010, end equals 2010. Good, looks like we have data on most countries. And let's just select, excuse me, I'm in my throat. Let's just table diff that. So what we're going to grab here is CO2 emissions. We might pull a couple others. And I'm going to select just ISO2C equals, so ISO2C and CO2 emissions equals this one. All right. Now we have yet another code that we might need to join between these data sets. So I'm going to take, actually think I can take this because I've got an I've already got this version that has 2-letter code. So I'm going to reuse that work and say CO2 emissions by ISO2C equals, it was called A2, it was. All right, so I was able to say for every country what it's, for each of the countries, I'm now bringing in a CO2 emission visualization. This is not exactly the topic of today's screencast, but I am actually curious, how does GDP per capita, I'm actually going to copy this, how does GDP per capita relate to emissions per capita? And it also makes me wonder, is there emissions per capita in our indicator? It just hit me that I didn't take a look at that. CO2 emissions. Wow, there's per person per something of GDP. That's curious. I'm not going to do that. Per US 10. That's other people are thinking along similar lines, but I just want to have CO2 and the word capita. Metric tons per capita. All right, that'll do. Oops. I was trying to copy this. So then, take this, save it, create it, CO2 emissions per capita, and look at GDP per capita compared to CO2 emissions per capita. This is very interesting. Just look at already. Let's see. All right. So what this shows is CO2 generally emissions per capita are there's like that type of pollution is highly correlated with a country's income. So you can probably, if we threw in a little more of one of these graphs, if I said geom text, throw in some do that population thing we were doing before, and do an arrange by descending total population. So some countries are emit more than you would expect based on their level of income, like China, India, a little above, some like Macau far lower. But most things fall right along the line. The U.S. is high emissions per capita, and like it's where we would expect based on its level of income. So that's something we learned is that like pollution is CO2 pollution is, but plastic waste is not. That's something we're now discovering. I can make a graph. I'm actually going to where I compare. Let's see, CO2 emissions to plastic waste. It's called. Oops. Mismanaged per capita. And yeah, the answer is it's the exact, so it might look like, oh, there's a relationship. But no, that's just because CO2 emissions per capita are very highly correlated with income. So we're seeing the same graph we saw before when we did it by income. So this is the graph I would focus on. That actually I think this is the conclusion we're coming up with, is that let's polish this up to kind of match the similar standards of this earlier graph. I'm gonna skip the leaving I'm gonna skip the coastal population side of this. What I'm doing right now is I'm figuring out. I figured out how to visualize the fact that country income is positively correlated with CO2 emission and negatively correlated with plastic, so that these types of pollution need to be considered separately. So I'm decided. I think what I'm going to do is create this first graph, save it. When I create the second graph, I'm going to save it as G2. Could just visualize it, but I could also use the patchwork library to combine both of these. What I'm doing is I'm taking G1, I'm redoing the title as emissions are correlated with GDP with country income, but not plastic waste. And now the reason I'm doing this is that with patchwork, we could actually have both these graphs pop up in the same plot. I think I can leave in. Yeah, so what I did is actually, it actually helps that I dropped the scale on this one. But now that I'm thinking about it, I don't want the other one to have a scale either. And I need some labels. So I'm going to copy these because they're already actually a solid start to some labels. Polishing graphs always takes at least as much code as creating the initial figure. So, and then Y is going to be CO2 emissions. And let's remind ourselves what it is. It's tons . I don't know, is it per year per capita? Sure hope so, because if typical human releases is responsible for 10 tons every day, that would worry me. I'm going to say tons per capita, just so that I'm not I'd rather be a little vague than be entirely wrong. I should have probably looked that up. But yeah, here's GDP per capita. The second one, I do not need. In fact, I must. It actually looks pretty good. Yeah, what we did is I said, here we go. CO2 emissions. The direction that I put those two in, I'm actually going to flip them, because I'd want we go. I actually want the emissions on the left. That's the direction that the text describes it. All right, so this is interesting. This is something we learn about types of pollutions countries can be responsible for. And it also shows that anytime we look at the analysis by country, we already had GDP. If I didn't, I definitely would have brought it in. And but we can also bring in other things like WDI, from WDI, World Development Indicators. All right, I'm going to take a look at one more indicator. And what I might want to take a look at is what else could be responsible for large amounts of plastic waste. So coastal area, It's called waste. Sometimes I wonder, does it have to do with something like infrastructure? All right, this is one thing that could be correlated. Investment in water and sanitation. Maybe. If I do a WDI, so I'm kind of just exploring here, getting a feel for what variables there's so many that are available, and look for the word waste. Or what was the other one that I wanted to look at? This is going to be correlated with GDP. It's not the right approach. How about, let's see. Oh, wow, there's quite a few. So one thing I'm interested in is mismanaged. I hear the word mismanaged, and I don't think generates a lot of waste. I think corruption, maybe doesn't have strong infrastructure in place and what's the word I'm looking for? Like institutions not being trustworthy. I am going to try the corruptions perceptions index. Let's see what that looks like. Can it even be downloaded? I'm going to say other data. I learned this last week from the creator of this package, is that, let me, of the WDI package, is that I actually can do renaming right here. I can say, well, I want to name this CO2 emissions per capita, so I can do CO2 emissions per capita equals this. Let me fix I'm creating this outside. All right, I'm going to do CO2 emissions per capita. I'm going to also get corruption perception index equals, and put that one. Right, and now let's see if it works. Look at that, the rename done as part of the stat. That's pretty cool. So what I'm going to say is we already have it joined with plastic data. I'm trying to clean this up so I'm not always repeating the same bits of code. Oops, country would be, I do need to remove the country variable from the other data, otherwise it's going to be joined, it would be joined in, which is no good. Great. All right, so I'm going to look at that distribution. Let's see, other data, I call it plastic with indicators. First of all, how many countries do we have a corruption perception index? Only 38. That's not enough. I wonder how many, let me see, what other metrics we might be able to use. Let's see. Try this one. I don't know what CPIA corruption is, but yeah, 117. That's a good deal better. What is this one? CPIA, transparency, accountability, and corruption. Can I search for it? One is low. Yes, okay. So this is a solid, I think, choice. What is CPIA? Okay. Certified Professional Insurance. Country Policy and Institutional Assessment. All right. So this is a measure of the trust in the public institutions. All right. So that's, I think, a solid direction we might go. Remember, I'm not a social scientist. I'm vaguely familiar with people working in this kind of area, but I'm actually going to name this transparency. CPIA transparency. And now here's our data all together. I'm going to say for only the ones that have a CPIA transparency, ooh, we lost a lot of data. That's too bad. If I arrange in descending population, do I at least have the big ones? I meant total population. Nope. We do not have ones for our richest countries. We don't have it for the United States even. Is that the case? If I looked at this, yeah, it looks like this is done maybe only on developing world countries or maybe in some other by some other definition. I wish there was some like standard metric that is really spread across everywhere. And afterwards, I'm probably going to get tweets and suggestions from people of metrics I could have used. I really just was interested in we ought to, let me see, control of corruption. Let's see how many countries have this one. Oh, it looks like most of them. Oh, nope, it is only, nope. Again, we don't have it in countries like the United States. All right. That might still be meaningful if these turn out to be the ones where we, so what we need to consider just that we're looking at a smaller subset of these. All right, so that's a bit, we're in a bit of an odd shape. All right, so let's ask the question though. Let's ask, what's the relationship between this and mismanaged per capita? We could always do a box plot with these. We need to, when we do a box plot with a numeric x, we need to say group equals. No, it doesn't look, we could look at whether it does, but have some relation when we add other metrics, but we can see that 1 is low, 6 is high, and some of the countries that we have a metric for with the highest mismanagement, with the highest like trust, have also relatively high levels of plastic waste mismanagement. So this was a bust. Looking by level by CPI trust rating is a bust. There are other ways we could look at it. We could have controlled for GDP or whatever, but I sometimes just you look at like your first variation here and you're like, no way is there going to be anything here. I'm actually curious if I look at this by descending CPIA transparency. What countries are at the top? This is the most trustworthy. All right, so India is fairly high, and it is, and what will be at the bottom? Sudan, Gambia, Guinea, Cambodia. Yeah, these didn't link up quite to the ones that had the highest levels of waste, a lot of which were islands. So we saw that. All right. So this analysis didn't work out. I'd be really interested in hearing from people what other people that have like social scientists, people study international relations, people that have a feel for, and certainly environmental sciences, that have a feel for what else we could compare levels of plastic waste to. All right. So what do we do today? We learned to clean a data set, particularly discovering that some part that it was missing lots. It didn't have data for over history. We did a scatter plot, and later we added a second scatter plot and showed how we can use that to showed how we can combine two scatter plots under one title and subtitle using the patchwork package to tell a bit of a more complicated story in just one graph. And finally, in the middle, we made a fun choropleth where we did a visualization of how much level of plastic waste. As soon as I see this, I realize that we really need to do gradient to low equals green. You're not supposed to do low green to blue to red. And midpoint. It's got to be, I think, log 10 of 0.2. I think I've seen that before. We have to make the middle some color. Like in this case, we'll have to make it pink. Otherwise, we get like areas that are entirely white just because they happen to be right at the median. Here we go. This will be one example of visualization. It's uglier than the other plot, but it gives more feel for like where are the problem areas. I think we have a blue to yellow actually looks really good, but I'm not gonna spend any longer on this. But yeah, so choropleth, some scatter plots, pulling in some data, exploring WDI for other indicators, and downloading a few that might have been useful. Okay, well, that's the time we have. I hope you had fun. I certainly did, and I'll see you next week.